Hello all, a very good day to all of you. In this class, we will discuss all the questions that have come from analog circuits in 2016 GATE examination for electrical engineering branch. Okay, so in 2016, right, there were total 3 questions that have come from analog circuits. 2 are of 1 mark and 1 is of 2 marks. So in total, 4 marks have been asked from this subject in 2016 for electrical engineering branch. So the first question is, the transistor circuit given below, right? The Zenon diode breakdown voltage is having 5.3 volt as shown in the figure, right? Take base to emitter drops to be 0.6 volt, VB given 0.6 volt, right? Then it is asking to find out the current gain beta. Okay, so let us see how to solve it. First point is, let us put a nodal equation at point B, right? So nodal at base. Okay, so the current here is 5.3 minus 10 by 4.7 K, right? This current here is IB, right? IB plus IB, right? Plus 0.5 milliampere is equal to 0, right? So in place, IB is equal to minus 0.5 milliampere minus, you see this 10 minus 5.3 divided by 4.7 K, right? Go that side, we will like this. Okay, so okay, it's equal to so I think there is a mistake here, right? Equal to, right? If it will go like this, minus 0.5 milliampere minus 5.3 minus 10 divided by 4.7 K, okay, equal to minus 0.5 milliampere minus, this is minus 4.7 divided by 4.7 K, okay, minus and become plus, equal to minus 0.5 milliampere plus 1 milliampere is equal to 0.5 milliampere. Okay, so IB is simple as IB is equal to 0.5 milliampere. Okay, this thing you know, right? One more thing is, we will do this. You know, if IB is this, what is I? I is nothing but 1 plus beta times IB, right? This thing you know. One more thing, what is B? B is B. This one, right? B. What is B? B is equal to 5.3 minus VB equal to 5.3 minus 0.6, right? 0.6 is the VB equal to 4.7 volt. Same place. I is equal to 1 plus beta into IB, right? Into IB equal to V by 470 ohm, right? This is my I is nothing but V by 470 ohm, right? This implies 1 plus beta equal to V by 470 ohm into IB, clear, equal to, what is V? V nothing but given 4.7 volt, right, by 470 ohm into, what is IB? IB is given 0.5 milliampere, so into 0.5 milliampere. Okay, so if you solve this, 10 get cancel, right? I got 20, right? 20 is equal to 1 plus beta. So this implies 1 plus beta is equal to 20. This implies beta is equal to 19. Okay, so the answer should be 19. It's a very simple question, right? Only thing is you have to apply nodal equation here. Then we know the VE. From VE I can know IE, right? Another equation to know IE is 1 plus beta into IB, right? From these two equations I can easily calculate what is the beta, nothing but current gain. Okay, the next question. In the circuit shown below is an example of which filter, right? So here you see, if frequency is low, right, if F is low, right, then what about this capacitance will be 1 by j omega c. So if F is low, this will be 1 by low is very very high. Very very high means I can say it's almost open circuit. If it is open circuit, what will be V out? V out will be minus R2 by R1 into V in, right? So if frequency is low, this is offering a very high impedance, almost like open. So my output will be minus R2 by R1. If frequency is very high, right? If frequency is high, very high, then 1 by j omega c, omega c, 1 by high is very very low, right? If it is very very low, I can say it is almost like a short circuit, right? If it is short circuit, right, because of virtual ground principle, 0 volt will be here, 0 will come to the output. So my output will be 0, right? So if my frequency is low, there is output. If frequency is high, output is 0. Okay, that means it is a low pass filter. Okay, this is the next question. In the circuit shown below, taking the op-amp ideal, right, find the output voltage in terms of the input voltages, right? So you know, for ideal op-amp, the gain equal to infinity, the input impedance is equal to infinity, bandwidth equal to infinity, and the output impedance is equal to 0, right? This is my ideal op-amp, right? So since there are 3 voltages, right, so let us solve the question using superposition theorem. Okay, so only V3 present, okay, the corresponding output is V03, okay, so V03 is the output only if the voltage source V3 is present. Okay, when V3 is present, this is grounded, this is also grounded, right? So when both are grounded, right, so here I got 0 volt, right? Because of virtual ground, I will get 0 volt here also, right? Let us now put a nodal equation at negative terminal, nodal at negative terminal, 0 minus V3 by 1 ohm plus 0 minus V out 3 by 9 ohm is equal to 0. Okay, simplest V0 3 equal to minus 9 into V3, right? 9 into V3. So in both B and C option is there, right? This is one equation. Second thing is only V1 is present. Only V1 is present. The corresponding output is V01. Okay. So when V1 is only present, so this will be grounded, right? And this will also grounded. This is not there. This is not there. Both will be grounded, right? Then what is V positive? V positive is V1 into 4 ohm divided by 4 plus 1 is 5 ohm. So 4 by 5 of V1 is my V positive, right? Because of virtual ground, right? V positive is equal to V negative. V negative is equal to 4 by 5 V1. Let's apply a nodal equation at this point, right? V negative by 1 ohm plus V negative minus V01 divided by 9 ohm equal to 0, right? This implies V01 by 9 equal to V minus plus V minus by 9, right? So this implies V01 equal to 9 plus 1, 10 V1, 10 V0, or 10 V negative. You see, this is negative, this is negative, okay? So 10 V negative, 10 into what is V negative? 4 by 5 V1 equal to 5. So I got 8, 8 V1 is V01, right? V01 is the voltage due to only V1 is present, right? This is equation 2. What is equation 3? Only V2 present. The corresponding output is V02. Okay, so only V2 present means V1 will be connected to ground. V3 also not there, connected to ground. Okay, so then what is V positive? V positive is equal to V2 into 1 by 1 plus 4 is 5 equal to V2 by 5. Because of virtual ground principle, we know V minus is equal to V positive is equal to V2 by 5. Okay, now let us apply a nodal equation at negative terminal. V negative by 1 plus V negative minus V02 divided by 9 equal to 0. Okay, V02 is equal to 10 V0 V negative equal to 10 into what is V negative means? V negative is nothing but V2 by 5 is equal to 2V2, equation 3, right? From equation 1, 2 and 3, V0 is equal to V01 plus V02 plus V03. Okay, what is V01 is 8V1, 8V1 plus V02 is 2V2 minus V03 is minus 9V3, 9V3. Okay, so if you see, this is the answer. So let's see what is the answer. Answer should be 8 plus 2 plus minus 9, right? 8 plus 2 plus minus 9. 8 plus 2 minus 9. So answer should be option D. Okay, it's a very easy question. Yeah, I think that's all of you. So thank you guys.